respected authorities of emerging information technology. I'm Shivashish Panchal, third year computer engineering student from TJ Sanghi College of Engineering, Mumbai. So, this presentation is about Internet of Things based home automation system. The abstract of the presentation: home automation project developed using Arduino, Pixim Lab Simulator, and Blink IoT mobile application. This project involves automatic garden light control, automatic temperature control system, water level control using serial tank, and displaying the active information of device behavior on an LCD. Learning from the internship, week 1. Introduction to C programming and its data types. Constructors and operators, arrays, pointers and functions, recursion, pointers, strings, and C++ essentials. In the week 1, the Emertxe professionals taught us about C programming language and its application in embedded systems. Coming week, week 2, Introduction to Internet of Things and Project Requirements. Introduction to Embedded Systems, LED programming, uploading hex file into the Pixim lab, and CLCD programming. So the professionals taught us about the Internet of Things and the project requirements at the end of the internship period. Introduction to Embedded Systems. They taught us that embedded systems are both hardware and software combination of particular project. LED programming and the uploading of hex file. Hex files are files that are converted into binary format of the .ini extended file of the Arduino programming language. In week 3, heading towards building the main project, we learned about Arduino module, then integrating the module into the Blink IoT application app, controlling garden lights using LDR sensor. Now LDR sensor is light detecting resistor. So it basically behaves opposite and inversely proportional to the intensity of light falling on it. The amount of light falls on it, its resistance increases, and thus the voltage decreases, thus breaking the circuit, and vice versa. Controlling the temperature system using Pixim Lab Simulator. Controlling the water level in the serial tank using serial tank monitor. Creating data streams and virtual pins to control peripherals using Blink IoT application. Now data streams are used to assign virtual pins to the widgets created in the Blink IoT application so as to control the peripherals directly using wireless medium. Week 4, Introduction to core job market and trends in the career fields of Internet of Things and embedded systems. The Emertxe professionals introduced us to the core job market of Internet of Things and the trends in the career fields related to it. They also helped us in developing skills related to resume building and also gave us a brief introduction about the placement opportunities available. Now the overview. Purpose: to automate simple appliances so as to reduce human work. The purpose of using Internet of Things and embedded systems is to reduce as much as possible the human work so as to simplify human life. Scope of the project: the home automation is simulated using Pixim Lab and Blink IoT mobile application to control the home appliances. Assumptions and dependencies: this project has been entirely executed using simulators and no real-time peripherals have been used for project implementation. Dependencies of this project are Arduino Sketch IDE, PixSimLab Simulator, Serial Tank, Virtual Serial Port, and Blink. In Arduino Sketch IDE, we would write the C embedded system code. In PixSim Simulator, we would simulate using peripherals and different input-output devices. In Serial Tank, we would display the water volume in that particular tank. Virtual serial port is used to generate a virtual serial port like COM1, COM2 pairs which are then connected. The simulator has is at the one end of the COM, and the serial tank is at another end of the COM. Blink IoT integration app is an app used to operate the peripherals wirelessly. So this is a pictorial representation of the project implementation. Garden light automation, the first step of the project. In this part of project, an LDR sensor is used to turn on off the LEDs. The working of an LDR is in such a way that when light falls on it, its resistance increases, which causes the circuit to break and vice versa. Therefore, during day when sunlight falls on the LDR, garden lights are turned off. During night, there is no external light, hence the LDR completes the circuit and garden lights are turned on automatically. This feature reduces human work by automating simple tasks such as turning on lights. On bottom right is the pictorial representation of the PixSim lab, the LDR and the LEDs present there. Temperature control system, step 2 of the project implementation. The temperature control system consists of a heating resistor, a LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on off the heater and the cooler through the Blink IoT mobile application. So about two steps are the steps to be performed in while controlling the temperature system peripherals. So top right represents the fan, which is the cooler, which also displays the ambient temperature and the current temperature of the surroundings. The next image represents the LCD display, which shows the ambient temperature, which is 27.37 degrees Celsius. Step 3 of the peripheral is serial water tank. So read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through Blink IoT application app, displaying the volume of water in the tank on the CLCD. So on the right side is the pictorial representation of the serial tank and the volume represented by the CLCD. 2270 liters of water in the tank currently being displayed. User interface. Blink IoT mobile application is used to ease the user interface. It is used to configure, operate and manipulate different peripherals present in an embedded system. It consists of lot of controllers, displays, interface and other features for development. In this project, widgets used are buttons, gauges and terminal notifications. Buttons are used to turn on and off the peripherals. Gauges display the temperature and the water level in the tank respectively. Terminal notifications are used to provide notifications for threshold limit. This is a pictorial representation of the Blink application app. On left side, it represents tab 1 for temperature control system, which consists of a cooler button and a heater button, a temperature sensor gauge and a notification panel. Right side consists of tab 2, which is for serial water tank inlet and outlet. inlet valve V4, outlet valve V5, and water volume gauge. Threshold control. This feature has been programmed into the project so that the maximum temperature that the heater can raise is still 35 degrees Celsius. It is a safety feature so as to avoid any accident. The serial tank also contains this feature. When the water volume reaches 3000 liters, then the outlet valve closes automatically, and when the water volume is less than 2000 liters, the inlet valve turns on automatically. This feature is integrated in both the peripherals so as to avoid any accidents or wastage. CLCD notifications: initial state, temperature, ambient, volume present in the serial tank. This state is when the cooler is off, as you can clearly see in the LCD, and inlet is on. This is displayed when the heater is on. When the heater is off, cooler off, and outlet on. Various other combinations can also be generated. Blink terminal notifications. Temperature is about 35 degrees Celsius, turning off heater. This notification is displayed on the terminal of the Blink app, which also adds the user interface of the application and ease of access, ease of use. Project implementation. So as you can clearly see, left side represents the Arduino sketch IDE, which consists of the code. Right side top right contains Pixim Lab simulator, and bottom contains the spare parts. The simulator has clock speed of 16 MHz, and it is also predefined, pre-uploaded with the hex file of home automation blink control.ino with bootloader. The spare parts consist of LEDs, LDR, temperature system, CLCD, and an Ethernet module. The next part contains the serial remote tank, where you can clearly see the serial port communication combine and various other values present in the application. On concluding the project, this internship project under the guidance of Emertxe professionals has been very informative, and I have learned and gained a beneficial experience in introduction to the field of embedded systems and Internet of Things. I have learned a lot of new things like Arduino, simulators, project programming, languages for development in this field. I really thank you to the Emertxe professionals for such a support. Thank you, Emertxe. Following is the representation of project demonstration. This is the code. Definition of the predefined libraries. Including the libraries SPI.h, Internet.h, Blink Simple Internet, and Wire.h, Liquid Crystal I2C. Having the Pixim Lab turned on. Loading the hex file. Sketch. Export compiled binary. As you can see, the file has been compiled. The new hex file has been uploaded. resetting the Arduino. So these are the spare parts. These are the LEDs. This is the LDR sensor. This is the temperature system, which consists of the cooler, displays the ambient temperature and the current temperature. This is the Ethernet module used to connect to the Blink integration app. This is the IC and the CLCT display. Going on to the Blink integration app. As soon as I turn on the heater, it displays heater on and the temperature increases. When the temperature reaches 35 degrees Celsius, it automatically turns off the heater and temperature reduces again. Furthermore, when I turn on the cooler, it displays cooler on, the fan starts rotating and the temperature reduces. On turning off the cooler in the Blink app, it displays cooler off. I also received a notification in the Blink app regarding temperature above 35 degrees Celsius, turning off the heater. Now moving on to the cereal tank. Going to tab 2 of the home automation app in the Blink IoT. Turning on the outlet valve, you can clearly see outlet flow on in the CLCD display. As soon as the volume reaches below 2000 liters, the inlet valve automatically turns on and the water starts filling into the cereal tank. Turning off the outlet valve, outlet off, and turning on the inlet valve, the cereal tank again gets filled. As soon as the volume reaches a value of 3000 liters, see here, the inlet valve is off automatically. This is the threshold limit automatic system programmed into the code so as to stop the water from getting wasted. Furthermore, the LDR sensor, as soon as the resistance decreases, LEDs turn on automatically. In real time, the sensor would work on automatically. So this was the demonstration of the project developed and the guidance of Emertxe officials. I would like to thank you for patiently hearing and watching my demonstration.